everyone. Today we will talk about the stand-alone system of the medical industry. In this section of the medical industry, there is a filling system that fills the empty bottle with pills and capping system that cap the bottle on the conveyor belt. The system is used a PLC as the control device. The bottle is loaded and unloaded by the operator manually onto the conveyor. Next, we would like to explain how the machine works and introduce our PLC program that fully controls this machine. The components in this machine include 8 input devices and 3 output devices. The machine inputs include 1 push button, 1 emergency stop button, 4 photoelectric sensor, which is load sensor, filling position sensor, capping position sensor, and unload sensor. They can detect the presence of the bottle to control the machine. The actual sensing distance is adjusted for sensing the bottle. The two magnetic proximity sensors, which is P1 and P2, are used to detect the linear position of the piston. For the machine outputs, we have 1 AC conveyor motor belt, 2 pneumatic cylinders that perform process of filling and capping. Before we go to the PLC program, let's see how it works. The start button is pressed, the machine is going into standby. The operator loads the bottle onto the conveyor, the load sensor is detected, and the conveyor starts to move. When the bottle reaches filling position, the conveyor will be stopped for filling the pills into the bottle. After complete, it will go for capping process. When the bottle reaches capping position, the conveyor will be stopped for capping the bottle. After the capping process complete, finished goods were moved to unload area for operator to collect it. For the purpose of controlling this machine by a PLC, the push button, emergency stop button, and sensors are wired to the PLC input module. The conveyor motor, filling, and capping are wired to the PLC output module. The PLC program consists of 8 rungs: 1, 2, 3, 4, 5, 6, 7, 8. When the start button is pressed, the machine will go to the standby with the condition of all sensors on conveyor is clear. The output 7 is connected series parallel with the start push button and the sensors for the latching of the program. Once the operator loads the bottle onto the conveyor, the load sensor is attracted. Thus, the conveyor motor will start to move and carry the bottle to the filling section. When the bottle arrives at the filling section, the filling position sensor will be attracted. The sensor will stop the conveyor and attract the filling process. When the filling process is attracted, it will extend the piston of the filling pneumatic cylinder. Then, attract the sensor P2. It will trigger the counter of the filling process at 1 count. Then the piston will return back and attract the P1 sensor to extend the piston again. The process will repeat until the counter reaches the number. In this case, we set counter number to 5. After the filling process is complete, the conveyor motor is attracted and the bottle is transferred to the capping section. The filling position sensor is unattracted when the bottle left the filling position sensor. When the bottle arrives at the capping section, the capping position sensor will be attracted. The sensor will stop the conveyor and attract the capping process. The piston of the capping pneumatic cylinder will extend until the timer is reached. In this program, we set 5 seconds for the timer preset. After the capping process is complete, the conveyor motor will move again until the unload sensor is attracted. By this time, it is waiting for operators to collect the finished product. Once the product is unloaded, the machine will go into standby. The process will start again when an empty bottle is loaded onto the conveyor. This system also included the emergency stop button, where it is used to stop any process during the emergency case. When it pressed, it will reset the filling process counter and capping process timer.